Hello. What we're going to look at now is a formula that's going to give us the terms, the numbers in our lists for linear sequences. So it's called the nth term. So it's going to be a formula that gives us the numbers in any of our lists if we have a linear pattern. So our very first job, whenever we're trying to do this, is going to be making certain we've got a linear pattern, or an arithmetic sequence, as we might call it. So again, what we're aiming for is there a formula, is there a rule that I can write down that would give me a number in this list? So I know the first 4 terms in this list. If I wanted to know the 50th term, would I be able to write down a formula that would allow me to just plug in n is 50 and say, well, I now know that the 50th term is this particular number. So is there a formula I can create that gives me any number in these lists? And there is. And there's 2 different ways that we can look at finding these linear pattern formulas. The first one is what we've got here, and it's going to be the difference between each one of the terms. We know for our linear patterns the difference is the same between each term times my term number n plus some constant would give me this formula. And we're going to put that into practice in a minute. It looks a little abstract to begin with, but it's fairly straightforward to implement once we get a little bit of practice with it. The other version of this is in page 22 of our log tables. So our formula tables, or our log tables, has this formula: Tn is equal to a plus n minus 1 times d. A is a letter for the first term, which we might more sensibly call T1, term 1. And it's our first term in our list. So in this case, it would be 4. That's the first term in our list. N is our term number. We tend to just leave it as n because we're looking for a general formula and we want to put in a particular value of n and find out our term in the list. And then D, or D1, stands for our difference between our terms, because we know for a linear pattern, linear sequence, that is always going to be constant. So let's look at both of these methods for finding our nth term, for finding our formula that gives us the numbers in this list. So the very first thing we have to do is, do I have a linear pattern? Well, let's double check. Here I go from 4 to 7, I add 3, add 3, add 3. Okay, so it looks like I've got a linear pattern. I have the same difference every time, and I know that that's my test for a linear pattern. So once I know I have a linear pattern, I'm going to start off by trying to use this method here. So I know the difference, D1, is going to be equal to 3. It's a constant, so it's a linear pattern, and it's equal to plus 3. So my formula here, my term number, I should say my nth term formula, is going to be the difference, 3 times n plus or minus some number. So I'm just going to say plus a number in this particular case. So I know it's in this general form. That's what my pattern has to be. Now I know that this formula has to generate all of the numbers in this list. So I know when n, I should say, is 1, that means that this should end up being 4. So T1 for this pattern is the number 4. So that means that T1 be 3 on 1 plus some number must be equal to 4. Well, that means that 3 plus the number must be equal to 4. Rearrange. K must be equal to 1. That means that my term, my nth term, must be E3n plus 1. And if we try to use that to form our numbers in our list, we'd have T1 would be 3 by 1 plus 1. That'd be 3 plus 1 is 4. And if we had T2, the second term, that should be 7. Well, if we put in 2, we'd have 3 by 2 is 6 plus 1 is 7. So we can see that this formula is giving us all of the numbers in our list. Now let's use the other method, our page 22 in our log tables, and see if we're able to work that out. So as with any formula, you write it down and then write down all of the different parts that we're going to put into it. So this time we're looking for Tn, so we don't sub anything in for that. But A is our first term, that's 4. And D, or D1, is 3. Now sub that in and tidy it up, and let's see if we get the same formula. So this is two different ways of approaching the same problem. And they're both useful in different contexts. So I have a number outside of a bracket, so I know I'm going to multiply by each thing inside. Tn is equal to 4 plus 3n minus 3. Tn is equal to 3n plus 1. And lo and behold, we get the same rule again. And again, if we put in T1, we get 3 on 1 plus 1. That would add up to 4. And we can do that for any of our numbers here. And we'll be able to find any number in our list. So we could put in n is 50, and we'd be able to find the 50th term in our list. So that's how that is going to work. Now let's do this for our example here. So we not only want to find Tn, we also want to find the 20th number in our list. So you are entitled in the exam to simply write out this list, to just put in a bunch of commas and go up. We've been given the first 4 terms. You would be entitled to just keep going, but they are entitled, examiners are entitled, to ask you for the 100th term. And it would start to get quite awkward if we had to write out 100 terms in our list. So it's much better for us to be able to know, and we're required to need to know, how to find our nth term anyway. So let's do that. What's the first thing I need to do? Is this pattern arithmetic? Is it linear? And what's the test for that? Well, am I adding on the same thing or taking away the same thing each time? And I am. So I have a constant difference. In this case, it's 3 again, same as we had the last time. So looking at our first method, I know that my pattern should look something like the difference times my term number plus some constant. And I know that the first term should be 3. So T1 should be equal to 3. So I have 3 plus k must be equal to 3. Well, if I rearrange that, k must just be equal to 0. That's a little bit unusual, but it's no great crisis. It just means that my pattern looks even simpler. It's going to be 3n plus 0, or just 3n. So I take my term number, I multiply it by 3, and that is going to give me my number in my list. So I can see that for T1, I just put it in n is 1 and I get 3. For T2, I put it in n is 2 and I get 6. And this all checks out. I'm just multiplying the term number by 3 each time. And if I wanted to find T20, that's the 20th term in my list. All I would have to do is put in n is 20, and I get that that would be equal to 60. So let's do it using our other formula. Our other way of looking at it, this is simply another way of approaching the problem, which can be useful, particularly when we get into more complex situations. So we have our pattern here, and we are going to say A, our first term is 3, and D is also 3. So Tn is equal to 3 plus n minus 1 on 3. Multiply a number outside our bracket by each thing inside the bracket. We have Tn is equal to 3 plus 3n minus 3. Tn is equal to 3n. So T20, exactly the same as before. We just sub in and we get 60. So that means the 20th number in this list is going to be the number 60. So the 20th term, so T20, if we kept writing this list all the way out, would be 60. So the 20th number in our list would be 60. All right, let's look at this example here. So we have, we're asked for Tn, and we're asked for when is Tn 25. So what number in our list, what term in our list would be 25? So this is a slightly different question than we had before. Before we were told the value of n, now we're looking for the value of n. What term number are we at? What's our first thing we have to do? Well, we have to make sure we've got a linear pattern. So do we have a linear pattern? We're adding 2 here, and we're adding 2 here, and we're adding 2 here. So we do have a linear pattern. Our difference between our terms is plus 2. So let's go with our first method. You know, the Tn should be our difference times n plus some constant. Now, we know that the first term, T1, should be equal to minus 3. So we have 2 times 1 plus k. That should be equal to minus 3. So we know that this is generally what our formula should look like. And now we need to anchor what this value of the constant is that we want to add on. So we have 2 plus k is equal to minus 3. And when we rearrange that formula, we get k must be equal to minus 5. So I know that my formula should be 2n minus 5. Now I want to know, when is that going to be equal to 25? So what value of n is going to make this equal to 25? So let's sub that in. So we have Tn is equal to 2n minus 5. And I want to know, when is that equal to 25? That's what this question means. So if we rearrange our formula, we want to get n by itself, so that we're solving the equation for n. And we must get a whole number. If we ever don't get a whole number in this situation, we know that we've made a mistake. So n must be equal to 15. We're only dealing in those whole numbers. Let's do this out using our other formula. Tn is equal to a plus n minus 1 on d. A is equal to minus 3. D is equal to plus 2. Tn is equal to minus 3 on n minus 1 on 2. Multiply that out. And we get Tn is equal to minus 3 plus 2n minus 2. So Tn is equal to 2n minus 5. And then we do exactly the same steps as we did before. I'll write it out for you for completeness. Now, could we test our answer on this? Well, I know that when n is 15, this is supposed to be equal to, this formula is supposed to give me 25. So is T15 equal to 25? Well, 2 on 15 minus 5. So I get 30 minus 5 is equal to 25. So this does indeed check out. I didn't make any mistakes. Now, finally, I'm asked for the nth term here. So my first job is always to check, do I have a linear pattern? So I have plus 3, plus 6, plus 12. So I definitely don't have a linear pattern. So right now, I don't have the tools to work out what this pattern is. So for right now, I can't go any further than that. So I just have to say, no, I don't know how to get the general term for this, or the nth term for this pattern, because it's not a linear pattern. So it's important we understand this only works, what we're doing here only works for our linear or arithmetic patterns. And that's what we need for now.